is Tarawad Anvari, and I'm going to give a talk on long-term adaptation in VR, retention of altered sensory motor contingencies through redirected walking. Most of us has worn a VR headset before, and I'm sure we all know the weird feeling of readjusting our orientation after exploring an immersive environment for some time. I often end up being surprised about where I am in my physical living room, and usually I need a few moments to look around, and sometimes my first steps back into reality feel a bit weird. And this is especially true when I have been doing redirected walking experiment. And that's because VR, and especially redirected walking, alter sensory motor contingencies between movement and visual feedback. So in this study, we first replicated the finding that immediately after exposure to manipulated environments, obvious effects on motor behavior can be observed. And in this plot, you can see how one of our participants walked in a curve when trying to walk in a straight line directly after being exposed to a curvature gain. However, the main aspect of this study was to observe long-term retention of these adaptation effects. In this plot on the right, you can see how the influence of exposure to the curvature gain was still visible 1 to 3 days later after being exposed to the real world. So in this study, we want to contribute to 3 things. First, we collected and now shared a multi-session longitudinal dataset on redirected walking adaptation. Second, we think it provides empirical evidence that sensory motor adaptation to manipulative environments can persist over multiple days. And finally, we believe that our findings contribute to a better understanding of human perception. Moreover, we hope that this vivid example of automatic human learning and the astonishingly rapid adaptability of human will lead to greater consideration of these abilities in the development of VR systems in the future. In our experiment, we mainly has 3 phases, starting with the adaptation phase. In this video, you can see how the adaptation phase of the experiment looked like. Basically, the task for the participant was to walk back and forth between 2 trees in a desert with a visible curvature gain of pi over 30. All in all, they walked back and forth 200 times in each session. So on the right corner here, you can see how the walking data looked like. As expected, participants followed a slightly curved path to stay on the white line between the 2 trees. And on the left, we can see the scene of the 3 in the desert that we just watched in the video. So to measure the effects of the adaptation phase, we performed more phases. In a blindfolded walk phase, participants had to orient themselves toward a white line and then walk in a straight line in the dark. And afterwards, they were asked to point back to their starting point. So here you can see the temporal progression of a blindfolded walking trial. And now let's watch a video on how a blindfolded walk looks like. Okay, so finally we had a threshold phase where we exposed participants to a range of curvature gains to estimate their perception threshold. So they walked between 2 trees, back and forth, and gave feedback via controller input, as you can see here in the video. To decide which gains to test, we used an adaptive algorithm, which we re-implemented in C# for direct use in Unity, and this is now available as a Unity package. All in all, participants did 60 trials with different gains in each threshold phase. But now let's talk about the design of our sessions. So we started on a Friday with a baseline session, which included measurements of perceptual thresholds and blindfolded walking to assess any retention. Then we continued data collection for up to 9 days, all of which included retention measurements, adaptation phases, and measurements of within session adaptation. The fifth and final sessions, which took place both on Fridays, included retention and perceptual threshold measurements. Okay, I already spoiled you these results, just because based on this plot from one of our subjects, it seems clear that there is some retention. By examining walking shifts, we can observe that shifts remain significantly higher than baseline across almost all sessions. Also, we realize that these effects decreased after threshold sessions on our fifth and final sessions, suggests the adaptation from exposure to various gains was happening. And this retention remains up to 3 days after the last adaptation session. We also looked at the walk orientation parameter of our subjects in the dataset. The walk orientation, or alpha, remained significantly higher than baseline across almost all sessions. And the effect decreased after threshold sessions on our fifth and final sessions, which suggests the adaptation from exposure to mixed gains. And this strong retention remains up to 3 days after last adaptation. So we found no significant shift of the perception thresholds compared to the baseline. And the retention of perception threshold, we could say that is not happening or was destroyed throughout the procedure. And this is actually consistent with previous findings by Bolling and collaborators in 2019. So from this experiment, we can draw 3 conclusions. First, that repeated exposure to a fixed curvature gain leads to robust motor adaptation in redirected walking, and this adaptation is retained across days and reinstated immediately when users re-enter VR. Also, after exposure to varying gains in the threshold phase, location and perception measurements showed no effect. So, what can we take away from all of this? Well, it seems that our brain can learn different mappings between physical movement and our visual virtual input. This can also be observed when we adapt to a new pair of prescription glasses. And this learning effect seems to start quickly, and its results seem to be stored in our visual system. So we can reuse it the next time we wear the same HMD device. And the curvature gains used in this study provoke an extreme mapping, but it seems that we can even learn that. So next time you have to readjust after spending some time in VR, remember, the motor visual systems in your brain might have just learned something new. Thank you.